Hello everyone, welcome back. So my name is Umesh, and a brief introduction about me is that I've done my graduation from Hindu College, University of Delhi. I've done my masters from Delhi School of Economics, and currently I'm pursuing my PhD in economics. So let's talk about a new topic. So in the previous topic, we had talked about the fact that your statistics can be in two parts, descriptive and inferential. So we'll be talking or we'll be starting with descriptive measures in statistics. Okay. So in the definition of statistics, we had seen that it's about collection, organization, and analysis of data. So sometimes what happens is this data can be very large, or the volume can be very large. So it's really important that you somehow minimize the data set without losing any relevant information. So in that context, let's see what frequency distribution means. Okay, so when observations discrete or continuous, so we'll see what these two terms means, are available on a single characteristic of a large number of individuals, it is necessary to condense data as far as possible without losing any information of interest. So for a variable, okay, so before let's not discuss this, let's see with the help of example. So what this actually means. So suppose you have the data for the height of all the males in a city. Okay. So you can do one thing is you can collect data for every male, okay, and mark his corresponding height. So this process will be very time consuming, and the data will be very large. Okay. So instead of doing this, what you can do is that you can mark, so this height is a variable, okay, and this variable will have different observations. Okay, so you can mark these observation or a list of this observation. Say suppose the height can vary from 160 centimeter to 170 centimeter, so you can mark all these values, or you can list all these values, and corresponding to each observation you can mark how many people or how many males are there. So how many males are there for the height of 160 centimeter, and similarly you can go on for the range that you have created for this variable. So corresponding to every observation, there will be a value of males. So suppose for 165 centimeter, there are 100 males. So the frequency of occurrence of 165 centimeter or this observation for this variable height is 100 times. Okay. So you have somewhere minimized the data set. Okay. No information is being lost. Every male is being covered, and the size of the data set is also being reduced. So this is what frequency distribution does, right? So if we read this definition now, you will be able to understand it better. So when observation, discrete or continuous, are available on a single characteristic, say height, of a large number of individual, it is necessary to condense data as far as possible without losing any information of interest, right? I hope this is clear now. So either you can mark the observation in this way, or you can create a range of observations. So suppose you want to collect the data of how many students have scored marks in this range, and in this range, and in this range. So you can mark this range, and the people who fall in this range are being recorded here. So this is the frequency of students who fall under this marks category. Similarly for this and for this. Okay, so this becomes your frequency. Similarly, this is your frequency of occurrence of these data sets or these observation values for the variable height. Sorry, I hope I'm clear now. So what is discrete data set? So discrete is basically something which is divided. Sorry, let me write it here. Something which is divided. What is wrong with this cursor? Divided. Okay, just give me a moment. Okay, something which is divided and separate. So let me explain. So this height of 165 centimeter is separate from this height of 170 centimeter, and it is independent and individual in its own, it is divided from this 170 centimeter height. Okay, so these are discrete variables, or the variable is taking discrete values or individual values, very specific values. Okay, and each value is independent and divided from the other value. Just as I can see here, this range of value is separate from this range of value, and there is no relation between these two values. Okay, it is divided and separate. These values are separate. So when such is the case, then such variables are called your discrete variables. I hope this is clear. Let's see what the other type of variable is. So in the class type 15 to 19, 20 to 24, so in this is the example we are talking about. This one, in this class type, so class is basically this interval. So every interval is a class interval. This is the term used. Okay. So for class type 15 to 19, 20 to 24, both upper and lower limits are included and are called inclusive units. So for discrete variable, both the upper and the lower limits are included while we collect data, or okay, well, while we try to uh, find associated values for a particular observation. So both these values are included. So we'll see that for continuous, this is not the case. So that is why it is also called inclusive data, because it is including both the upper and the lower limit. So just remember this. This is for discrete. Let's see what continuous frequency distribution means. So suppose we have a distribution of age. So we have taken now the example of age distribution in years with the class intervals this and this. So we have used the previous class interval and we are having a distribution of for the age variable. So age is the variable here, and we are trying to find how many people lie in this range and this range and in this range. But if this is the case, if we use this type of interval, then what happens is in this process, the people between 19 and 20 years of age are missed. Okay, so if this is the interval that is being created, it means that the age or the people with the age of 19.5 years or 24.6 years, such people are not being included in the data. So this is a drawback of the discrete variable. Okay, discrete form of the variable. So we have a different form, which is the continuous form now. So we know that discrete is separate and divided, but in the context of continuous, it is not separate and it is not divided, and there's a continuity in the class intervals. These intervals have a continuity. So the first, so we can create a different distribution. So the age can uh, be from 0 to 5. So we can collect the data of individuals from 0 to 5 years of age, and we can mark the frequency. Then we can go for 5 to 10 years of age. Then we can go for 10 to 15 years of age, and similarly we can go on for other age range. Okay, so the catch here is that to maintain this continuity, the upper limits are excluded. So in this range, in this class interval of 0 to 5, the people with the age of 5 years are not counted in the frequency distribution. Okay, so the upper limits are excluded. Okay, so the person with 5 years of age will be a part of this interval. So in here 5 will be included, but 10 will not be included. So upper limits are excluded and are called exclusive class. So the discrete was called the inclusive class because both the upper and the lower limits were included, and the continuous variable is called the exclusive class, where because the upper limit is being excluded. So I hope this was clear. This was the basic introduction of your descriptive statistics. So we'll talk about uh, other things in the next video. Till then, take care. Thank you for watching.